Alright, hey guys. I hope you had a great Thanksgiving. Sorry I can't be there right now, but we will be doing notes today, unfortunately. So, the sub should have given you the lesson 3-1 notes, and that's what we will be doing today through this video. Okay, if you have any questions after the video, you're more than welcome to go ahead and email me after today. You will have homework afterwards, and I hope this video is enough for you to be able to figure those out. Okay, so we're not going to be doing the entirety of activity 3. We're just going to be doing lesson 3-1, which is called 2-column proofs. After we do lesson 3-1, we'll start activity 6, which is called geometric proofs, and starting with that. But for right now, we're going to just give an introduction to proofs with this lesson 3-1. Okay, 2-column proofs. If you can think about it, it'll be dealing with proofs that have 2 columns, okay, based on the name. Our learning targets for this lesson are to introduce the concept of a mathematical proof. Of course, there's a typo. Would you be surprised if there wasn't? Then we will also use properties to complete algebraic 2-column proofs. So this lesson will be dealing with mostly algebra, guys, and we'll be using algebra to do some proofs today. And this is just a good way to introduce these proofs before we actually get to what the proofs are in geometry. So what is a proof? So first off, let's talk about what a conjecture is. In mathematics, a conjecture is a guess that you make without any justification to back up your claim. All right. For a conjecture to be true, you have to prove that it is true using logical reasoning. So basically, just sound reasoning to be able to show that something is true. And if you think about it in real life, anything that you do has to be backed up with some kind of reasoning. Meaning, like anything you say, if I say this is it, I'm not going to take your word on that. I need to know that for sure that it's true, and I need you to show me somehow that it's true with some kind of logic. So, to do this, you have to use statements that you either know to be true because they've been proven already, or you will use statements that are assumed to be true without proving true. These are what we call postulates. These postulates that we've already done before, these are statements that we assume to be true without having to prove them, and we will use these to prove other things. So this process of using true statements to justify the truth of a conjecture is called a proof. Okay, so we can formalize just justifying statements and proving things by calling it a proof, and that's what a mathematical proof is. In algebra, every time you solve an algebraic equation, you are using properties that you've been taught are true, okay, to reach a conclusion, which in essence is the solution to the equation. When you solve an equation, you aren't necessarily proving that the properties are true, but you are using these properties, you are using these properties that you are assuming to be true, and these properties help you solve the equation. So if when we're solving an equation, we state the property after every step that we use to solve the equation, we are essentially proving that the answer that we get is true. Okay? So what I want you to do, it says read over these properties to the left. So first thing we're going to do before we even do these P1 and P2, we're going to go through what the properties are. And you should have seen these in that worksheet, that algebraic properties worksheet I gave you, but let's go ahead and formally go over these. So first, we have the addition property of equality. What this says is if A equals B, then A plus C equals B plus C. What this means is that if I have two things that are equal, I can add the same thing to both sides, and that's by the addition property of equality. So whenever you're getting rid of a negative number in an equation, you add that number to both sides, and that gives us that allows us That's by the addition property of equality. Number 2, the subtraction property of equality says that if A equals B, then A minus C equals B minus C. That means that I can subtract the same thing from both sides of my equation, and that's by the subtraction property of equality. Number 3, the multiplication property of equality says that if A equals B, then A times C equals B times C, or C times A equals C times B. This just means I can multiply the same thing to both sides of my equation. Multiply. All right, 4, division property of equality. If A equals B, and if C is not equal to 0, then A divided by C is equal to B divided by C. Okay, that means I can divide the same thing on both sides of my equation. And we put C not equal to 0 because you cannot divide by 0, and that's why we do that. 5, the distributive property. So it says that A times B plus C is equal to AB plus BC, or if you want to do it the other way, B times C times A is equal to BA plus CA. All this you know with the distributive property. You do it whenever you solve your equations. Remember, we just A times B and A times C right there. That's kind of how it looks. So we should recognize the distributive property. The reflexive property, number 6, says that A equals A. This is kind of redundant. You'll use this later on in some geometric proofs when we talk about proofs of triangles, but it just means that a value is equal to itself, and that's kind of easy to think about, right? Just know that's the reflexive property. 7, the symmetric property. The symmetric property says that if A equals B, then we also know that B equals A. It means we can just switch those around and we still have the same equation. Okay? You'll use this sometimes because in proofs we want our x usually on the left side of the equation. So if we end up with the x on the right side, we can just switch it around, and we can do that by the symmetric property. The transitive property, it says if A equals B and B equals C, then A equals C. So I have that B is equal to both A and C. If two things are equal to the same thing, so what I mean by that, if A and C are both equal to B, then A and C have to be equal to each other. So I like to write if two things are equal to the same thing, they are equal to each other. That's how I think about the transitive property. All right, you'll use that more in geometric proofs, and I think you've seen that on the worksheet that we did as well. Okay, the substitution property. It means that it says that if A equals B, then A can be substituted for B in any equation or equality. This is basically what we did when we were doing our things with whenever we did our equations in activity 4, solving for x, we substituted whatever we had for x in whatever the number we got for x when we solved the equation. We subbed that in to find the angle measure. So that's what substitution is, okay? Just plugging in numbers for variables, pretty much. Okay, so let's look back at P1. It wants us, and for P1 and P2, it wants us to read over the properties to the left, then solve each equation in P1 and P2. We want to show every step, and I mean every step, don't skip any steps, and name each property used to justify each step. So the first thing I think I'm going to do is go ahead and solve the equation in P1 first, and then we'll go back and write the properties that we use to solve each step. So if we look at our equation in P1, it says 4x plus 9 is equal to 18 minus 0.5x. So the disclaimer here, the way I solve the equation is not the only way to solve this equation. You can do these steps in different orders, and that's okay. If you solve this and do it in a different order, that's all right, but just make sure we know which property we're using to do this. So all right, let's go ahead and solve the way I'm going to do it. First thing I'm going to do is I'm going to add, let me do this in a smaller font, excuse me. I'm going to add 0.5x to both sides. Okay, and then that leaves me with 4.5x plus 9 is equal to 18. Okay, so next I'll subtract 9 from both sides, which will leave me with 4.5x is equal to 9. Then I'll divide both sides by 4.5, and that leaves me with x is equal to 2. Okay, so let's think of what we did. Let's go ahead and try to write down the properties that we used. So from step 1 to step 2, I added 0.5x. So the property that tells me I can add the same thing to both sides is the addition property of equality. And I put this, I abbreviated or shortened this to this right here, if you can understand that. Okay. Next, from this first arrow to this next arrow, I am subtracting 9, right? So if I'm subtracting the same thing from both sides, this is just the subtraction property of equality. And then lastly, I'm dividing 4.5 from both sides. So that is the division property of equality. And with that, we're finished with P1. So now let's do a similar thing for P2. Okay? P2. I have the equation 4x plus 18 divided by 2, all of that over 2 is equal to x. First step, what I do, I want to get rid of that 2 in the bottom. So I'm going to write this next step right here. So 4x plus 18 divided by 2, and I want to multiply both sides by 2 to get rid of that 2 in the bottom, right? Because these are going to cancel. Okay, so my next step, I've got 4x plus 18 18, sorry, is equal to 2x. Okay, let's how about we subtract 4x from both sides. Okay, this will leave me with 18 is equal to negative 2x. Right, because 2 minus 4x is negative 2x. Now let's get x by itself by dividing by negative 2 on both sides. So x is equal to negative 9. But remember, I want my x on the left side. And we'll get used to doing this. I want my x on the left side when we do these algebraic proofs. So my last step will be x is just equal to negative 9. Alright, so let's write down these steps. Write down the properties, excuse me. So the first thing I did right here is I multiplied both sides by 2, right? So to do that property that tells me I can do that is the multiplication property of equality. Okay, I'm fine with you just writing multiplication property. So then from this step to this step, I just simplified that. If it doesn't match any of the properties we're doing, if all we're doing is cleaning up both sides of the equation, you write simplify, because that's what I'm doing. I'm just simplifying this equation. Okay, then from this step to the next step, I subtracted 4x from both sides, so that would be the subtraction property of equality. So I'll just write subtraction property. Okay, and then from this step to this step, I divided both sides by negative 2. So this would be the division property. And then I solved for x. Right here I have it, but remember I want my x on the left side. So to switch these around, the property that tells us we can do that is the symmetric property. Okay, and we're finished with P2. So you kind of see how this is going. Like we're showing every single step of everything we do. Okay, this is kind of rough how we have it now. We're going to try to formalize it into a more aesthetically pleasing and more formal proof. Okay, so let's read what we have right here. Okay, so it says you can organize the steps and reasons used to justify the steps in two columns with statements on the left, and these are just the steps that we take, and reasons or properties that we're using on the right. So if you look over here, this is how it's kind of going to look. Statements and reasons on the right. This format is called a two-column proof. Each two-column proof will have a given and a prove statement. The given statement is what you start with. So basically the equation we're trying to solve is what we call the given statement. And then the prove statement is the solution to the equation. Okay? And that's what we're trying to show. So when you're writing two-column proofs, you need two columns, okay? And you draw this little T chart out. So we have this horizontal line, then you draw a little T, basically like that. And then on the left, we have statements, so you write that up at the top, and then reasons on the right column, okay? When you're doing these two-column proofs, you have every line of the proof is numbered, okay? So our first, remember we said the given statement is what you start with, and the first statement of every proof you do is the given statement. So number one, I'm just going to literally write what it says under the given right here. So I will write 3 times x plus 2 minus 1 is equal to 5x plus 11. So then my reason for this is literally just the word given. That will be how every two-column proof you will do, okay? The first step is always the given. And now we solve the equation. So, step 2. What I want to do first, let's go ahead and distribute this 3 times x plus 2. So this will be 3x plus 6 minus 1 is equal to 5x plus 11. Alright, so that'll be by the distributive property. Okay, so I want to kind of clean up this equation now, so let's do that. 3, so 6 minus 1 gives me 5, so this will be 3x plus 5 is equal to 5x plus 11. And remember, when we just kind of clean it up, this is by the simplify. Okay. So how about I subtract 5x from both sides? So if I do that, I'm left with, so 3x minus 5x gives me negative 2x plus 5 is equal to 11. So if I'm subtracting the same thing from both sides, that's just by the subtraction property. Okay, so now let's get rid of this 5 on this side. So if we subtract 5 from both sides, we'll be left with negative 2x is equal to 6, right? So this is again by the subtraction property, because we subtracted 5 from both sides. Last step, I want to get x by itself, so we divide both sides by negative 2, and we're left with x is equal to negative 3. So number 6, if we divide both sides by the same thing, we get the division property. And of course, guys, you could have done this in more than 6 steps. That's fine, but that's what I did. Okay, I went ahead and did it in 6 steps. If you work this out and you did it in 8 steps, and you showed every step and got the properties right, that's completely fine. Okay, that's the beauty of proofs, is that they're different. It makes it harder for me when I grade your work because I have to make sure you did everything correctly. But what I did is not necessarily what you did. But it doesn't change the fact that whatever you do has to be correct, at least, you know. So if you have any questions with any of this stuff, because it could be different, it's not exactly the same thing I do, let me know, please. Okay, number 4. So, it says to supply the reasonings to justify each statement in the proof below. So, we are given this equation x minus 3 over 2 is equal to 6 plus x over 5. We want to prove that the solution to this equation is x equals 9. So, all we're doing is writing the reasons this time. Okay, looking at our properties and using that. This first statement is the same as our given statement, so we know this is given. It's our easiest one right there. Okay, so to get from 1 to 2, we multiplied 10 by both sides. So if we multiply the same thing to both sides, it's the multiplication property of equality. And I'm just going to write multiplication property because that's fine with me. Oops, sorry. Next. Okay, so to get from 2 to 3, it looks like we did 10 divided by 2 and got this 5 right here. Then 10 divided by 5, it got me this 2 right here, and we just simplified what we did. Cleaning it up, cleaning the equation up. Okay, so then to get 5x minus 15 equals 12x plus 2x, 12 plus 2x, excuse me, we distributed both sides of the equation, right? So this is going to be the distributive property. All right, so then from 4 to 5, they subtracted 2x from both sides. Okay, so that is the subtraction property. Okay, then we want to get this negative 15 away, and that's what we did from 5 to 6. We added 15 to both sides by the addition property. And then dividing both sides by 3, we get that x is equal to 9 by the division property. I'll be honest with you, just writing the reasons is much easier than doing the whole entire proof, but that's not all I'm going to ask you to do, guys. But we are done with this problem, P4. We'll move on to the next problem. So, P5 wants us to complete the proof statement and write a 2-column proof for the equation in P1. Number each statement and the corresponding reason. So we're just basically writing a 2-column proof, okay, based on what we did in P1. So let's look at what we did in P1. All we did was we solved this equation in what? 1, 2, 3, 4 steps, okay? So our first, remember we know that our first statement is always what the given statement is, okay? So it's just writing down the equation that we have to solve. So number 1 is 4x plus 9 is equal to 18 minus 0.5x. And that is by given. If we go back up here, our next step, we added 0.5x to both sides, and we got 4.5x plus 9 is equal to 18. So let's write that down. 4.5x plus 9 is equal to 18. And what we did was adding that 4.5x, remember we said that was by the addition property. Excuse me, can't write today. The addition property. So step 3, we subtracted that 9 from both sides. And we said that was by the subtraction property of equality. So we got 4.5x is equal to 9 by the subtraction property. So again, I want to remind you that when we're doing these 2-column proofs, you need to be numbering every step so I know which statement corresponds to which reason. If you don't do that, you will be marked off because you have to be numbering each step. Alright, anyway, number 4. If we look back, we divided both sides by 4.5, excuse me, and then we got x equals 2. And since we divided both sides by the same thing, that was of course by the division property. So our proof statement, remember our proof statement is always the last statement of our proof. So this is going to be x equals 2, and we're finished with P5. Okay, all we did was take what we had from P1, what we've already done. We've already solved it and written the properties. We just wrote it nicely as a 2-column proof. All right, P6. Jeffrey wrote a 2-column proof to solve the equation 3 times x plus 5 is equal to negative 6x plus 6. In addition to an incorrectly written proof statement, so apparently this is wrong right here, what error did Jeffrey make in his proof? Make corrections to his proof so that it correctly shows how to solve the given equation. Alright, so let's just check his proof first. We know the proof statement is going to be wrong, so he did something wrong along the way. Alright, so step 1 says 3 times x plus 5 is equal to negative 6 plus x. That looks the same as the given statement, and this is a given for the equation, so that looks right to me, so we're good with the first statement and reason are good. Number 2. So it says we use the distributive property as the reason, so let's check and see if they did that correctly. 3 times x is 3x, 3 times 5 is 15, okay, good, and that's the same, so that's correct as well. Now, they said the next thing they used was the addition property of equality, so they should have added something to both sides, and what it looks like they did is they added 6x to both sides. And let's check. 6x plus 3x is 9x. That's the same, and that goes away, so that is correct as well. Okay, they say subtraction property of equality next. It looks like they subtracted 15 from both sides. That's correct, leaving with 9x on that left side. 6 minus 15 is negative 9. Okay, that looks good as well. So, from 4 to 5, it says they did the multiplication property of equality. So, ooh, okay, this looks like a mistake because to get rid of this 9, I'm not multiplying, I'm going to be dividing. So it looks like Jeffrey made a mistake in saying that he did negative 9 minus 9 to get negative 81. So that's incorrect. So our correct way to solve this one would be what? To divide both sides by 9. And when we do that, we get x is equal to, so negative 9 divided by 9 is just negative 1. Okay. So that means this would be, instead of multiplication, it will be division. And then instead of x equals negative 81, it's x equals negative 1. Because that's our last statement of our proof. And that's the only mistake he made, guys. So we fixed those two, and now his proof is correct. Okay, so P7. Identify the property that justifies the statement. If 4x is equal to negative 7, excuse me, 4x minus 3 is equal to 7, wow, then 4x is equal to 10. So think about it this way. So let's just write this as an equation, or as like we were solving the equation. 4x minus 3 is equal to 7. Then you have 4x is equal to 10. So what they did, it looks like they added 3 to both sides. Plus 3, plus 3. So the property that tells us we can add 3 to both sides is, of course, the addition property. And awesome. And that's it for that one. Number 8, P8. We're going to be looking for and making use of structure. So suppose you're given that A equals B plus 2. Then we've also got that B plus 2 equals 5. Write it like this. So we have two things that are equal to B plus 2. That's A, and we have 5, are both equal to B plus 2. So if I know that both of those are equal to B plus 2, then it's just logical to say that A is equal to 5. And that's by the transitive property. The transitive property tells me if two things are equal to the same thing, then they're equal to each other. So our answer for this one is A is equal to 5. And guys, that is it for lesson 3-1, or what I have for you today. Okay? So on the back of your notes, you should have the lesson 3-1 homework. Alright, so we've only done about 29 minutes today. You should have a little bit of time to work on this homework in class. This homework will be due tomorrow, which is Tuesday, by 3:11 p.m. So since we're back 5 days a week, your homework is due the next day, okay? So tomorrow by 3:11 p.m. If you have any questions with the homework, feel free to email me. I have my phone on me right now, and I can answer emails if you have any questions, okay? So I think we have enough information for you to be able to do the homework and be able to have it due tomorrow, okay? Tomorrow we'll work on some review of some of our angles and things we've talked about with angles and segments, because on Wednesday we will start geometric proofs, okay? So we've had a little bit of an introduction to proofs, so with this lesson, so we'll get a review of what all we know about angles and segments and stuff like that, and what we know about geometry so far. And then on Wednesday we will start chapter 6, or activity 6. So I hope you all had a good Thanksgiving. Thanks for watching this video. Email me if you have any questions, guys, and be good for yourself, please. All right, have a great day, guys.